we have an equation y equals to x cube minus 6x square plus 9x plus 2. Let's assume that this is the graph of this equation. So let's look at the graph. At first, the curve was very steep and the value of the gradient was very high. But as time goes by, the steepness of the curve decreases and the value of the gradient also starts to decrease. And at point A, the value of the gradient practically becomes 0. dy by dx is equals to 0. Why? Because if we draw a tangent at point A, the tangent will be perfectly parallel to the x-axis. Now, after A, the curve goes downhill and the value of the gradient becomes negative. As it going downhill, the value of the gradient will be negative. But as time goes by again, the steepness of the downhill curve starts to decrease and the value of the gradient from negative starts to increase. And at point B, again, the value of the gradient dy by dx becomes 0. If we draw another tangent at point B, this tangent will also be perfectly parallel to the x-axis. This is the x-axis and this is the y-axis. Now, these 2 points, the maximum, or we should say the point A and point B, these 2 points where the gradient dy by dx is equals to 0, we call them the stationary point or the turning point. They are called the stationary point and we can also call them the turning point. Okay. It is very important that we clearly understand the stationary points because this will be very important to understand our today's topic, maxima and minima. Now let's look at how maxima and minima will look like. Now let's look at the graph again. With respect to A, let's say we are considering point A. Before point A, the value of the gradient was positive. It was coming from a positive value. And then at point A, it practically becomes 0. And after point A, the value of the gradient becomes negative. Okay. Now, if we calculate the rate of change of gradient, if we calculate rate of change of gradient with respect to point A, rate of change of dy by dx, the gradient, this is less than 0. Why? Because it's a negative trend. It's going from positive to 0 to negative. Now let's look at point B. If we talk with respect to point B, before point B, the value of the gradient was negative. Then it becomes 0. Then it starts to rise again. From here to here, it starts to rise again and the value becomes positive. So it's a positive trend. Now if we calculate the rate of change of dy by dx for point B, rate of change of gradient, or we can just write dy by dx, this will be greater than 0, right? Okay, now how do we find the rate of change of gradient? We know that dy by dx, this calculates, dy by dx calculates the first derivative. This is the first derivative, and the first derivative shows us the rate of change of y with respect to x. How do we find the rate of change of gradient? If we want to find the rate of change of gradient, we have to use the second derivative. What is the second derivative? The second derivative is simply d square y divided by dx square. This is the second derivative, and this gives us the information about the rate of change of gradient. Okay, now if we go back to point A, at point A, the rate of change of gradient is less than 0. So for point A, we can also write, let's write it here, point A, we can write d square y divided by dx square, this one is less than 0. And for point B, we can say that d square y divided by dx square is greater than 0. Now, where the second derivative is less than 0, we call that point a maxima or maximum point, local maximum. And the point where the d square, second derivative d square y divided by dx square is greater than 0, we call it the minimum point. So if we can find the second derivative, we can compare it to 0 and we will easily understand which stationary point is maxima and which stationary point is minima. Now let's see some questions and how we can apply all these theories that we learned here to solve those questions. For the first example, we have an equation and we have to find the stationary points of the curve, stationary points on the curve of this equation, and we have to determine the nature. That means that we have to determine if the stationary points are maxima or minima, or which one is maxima and which one is minima. The first thing we know about stationary points is that the gradient is practically zero at a stationary point. So what we are going to do, our first step is to find the gradient. How can you find the gradient? By the first derivative dy by dx. So if we apply the power rule, we are going to get 6x squared minus 6x minus 12. And we know that at stationary points, this one will be equals to 0. So if we simply solve this thing, we are going to get x minus 2 and x plus 1 equals to 0. So the x coordinates are 2 and minus 1. Now that we have the x coordinate, let's use the x coordinate in that equation and find the y coordinate. When x is equals to 2, if we calculate y, you can get 2 multiplied by 2 cube minus 3 multiplied by 2 square minus 12 multiplied by 2 plus 5, which will give you an answer of minus 15. So one of the stationary points has a coordinate of 2 minus 15. Now let's find the other one. X is equals to minus 1, the second value. Then we are going to get y equals to same thing, just we are going to replace with minus 1. Minus 1 cube minus 3 multiplied by minus 1 whole square minus 12 multiplied by minus 1 plus 5. If you solve it, you're going to get a value of 12. So the other stationary point's coordinate is basically minus 1, 12. Now that we have the stationary points and we have the x coordinate, we can find the second derivative. When you find the second derivative, we know how to find the maxima or minima. Let's find the second derivative. It's d square y divided by dx square. How do you find the second derivative? You just differentiate the first derivative again. This was our first derivative. We differentiate it again. That means we apply the power rule here again, and we will have our second derivative. So apply the power rule. So you're going to get 12x, and this one just become minus 6. Okay, this is our second derivative. Now let's apply the value of the x coordinate from our stationary points and see how it becomes. Let's say x equals to 2. Then d square y divided by dx square will become 12 multiplied by 2 minus 6, which gives us the value of 18. And this is greater than 0. When we know that when the second derivative is greater than 0, that is a minima. So this point is a minima. Let's find the other one. X equals to minus 1. If we put that, then our second derivative d square y divided by dx square becomes 12 multiplied by minus 1 minus 6. So that gives us the value of minus 18. Now we know that when the second derivative is less than 0, that is a maxima. So this stationary point is maxima. So just like that, you can follow the 3 steps. You find the gradient first, apply the stationary point formula equals to 0, then you find the x coordinate, use the x coordinate, find the y coordinate, and then use the second derivative and judge their nature. Very easily, you can solve any question about maxima and minima. Let's solve one more math. This time, in our equation, we have a fraction, but we know that we cannot apply the power rule directly here. If you don't know how to apply a power rule here, I suppose you go back to the power rule video. It will be very easy for you. We can solve any equation with a power rule then. Okay, so first thing we are going to do is we are going to bring that x up and write it as a numerator, right? Then we go to find our gradient. So when you differentiate it, you simply get 1 minus 4x power minus 2. Now at the stationary points, this is equals to 0. So we can just write 1 minus the 4x power minus 2. We can write it as 4 divided by x square. This is equals to 0. That means 4 divided by x square is equals to 1 and x squared is equals to 4. If we square root the x, we are going to get two values, plus 2 and minus 2. Now that we have the value of x, we can use the value of x and find the coordinate of y. When x is equals to 2, if we put it in y, we're simply getting 2 plus 4 divided by 2, which is equals to 4 plus 4. So one of the coordinate of one of the stationary point is 2, 4. If we apply the other one, x equals to minus 2, we are going to get y equals to 2 minus 2 minus 4 divided by minus 2. So that gives us minus 4. So the coordinate here of the other stationary point is minus 2, minus 4. Okay. Now that we have the coordinate of the stationary points, we need to find the second derivative. Let's find the second derivative. Second derivative is d square y divided by dx square. How do we do it? We simply differentiate the first derivative again. This is the first derivative, so differentiate it. 1 will be gone. There is no variable there, so don't need it. So it's simply going to be 8x power minus 3, or we can write it as 8 divided by x cube. Now let's apply the value of x. When is x is equals to 2, this simply becomes d square y divided by dx square. The second derivative simply becomes 8 divided by 8. 2 cube, so that's 8. So this is 1. Now this is greater than 0. So when we have x equals to 2, this is our minima. Now the second one, when x is equals to minus 2, if we find the second derivative, d square y divided by dx square, we are going to get 8 divided by minus 8. A cube on minus 2 will yield the result in negative, so the result will be minus 1, which is less than 0, and when it's less than 0, we know that it's maxima. So this point here, this will be maxima. This is how you can use the power rule, the gradient formula, and also the stationary point thing, and use the second derivative to find which one is maxima and which one is minima.